All right, everybody, let's look at lesson 4, which is going to talk about equilibrium. Equilibrium is the rate of the forward reaction is equal to the rate of the reverse reaction. Equilibrium is a dynamic process because everything's in constant motion, and it's represented by a double arrow. So in our equations that we are going to see, we're going to have this double-headed arrow because that means that this reaction can go in this direction or in the reverse direction. So there are types of equilibrium that occur, and they all occur in closed systems. So the first is a physical or phase equilibrium. That's when the rate of the forward phase change equals the rate of the reverse phase change. So for example, the rate of vaporization is going to be equal to the rate of condensating. So H2O as a liquid is going to be equal to H2O as a gas. So that means that water is vaporizing at the same time that it is also condensing. The second type of equilibrium is chemical equilibrium. That's when the rate of the forward reaction is equal to the rate of the reverse reaction. So an example of this would be the Haber process. So the rate at which N2 and H2 combine to make ammonia plus heat is going to be the same rate as the reverse when NH3 plus heat breaks down and makes N2 plus H2. Solution equilibrium is when the rate of dissolving equals the rate of precipitating. So when we look at sodium chloride as a solid dissolving into the sodium ions that make it up in aqueous solution, the rate that is dissolving is going to be equal to the rate that it's going to precipitate back out of solution. So when we look at solutions, there's a constant equilibrium because things are going to be precipitating out of the solution as well as dissolving into the solution. So will a reaction happen on its own once it's started? If reactions are spontaneous, then they will happen on their own once it's initiated. Things that occur this way are exothermic reactions because there is a lower activation energy, and if there's an increase in entropy. Those two things happen spontaneously. Remember, we've talked about entropy before, but entropy is the randomness or disorder of a system. So the more substances you're making, the more entropy you have. And the higher temperature you have, the more entropy you have. So changes in entropy. Entropy and states of matter. So as we look at these different states of matter, we're increasing in entropy. So gases have the most entropy, they have the most disorder. Solids have the least amount of disorder. Liquids and aqueous solutions fall in the middle. But as we go from left to right, solids have the least, then it's liquid, then aqueous, then gas. So let's look at some examples. Determine if there is an increase or decrease in entropy. In the first equation, there is going to be an increase in entropy because you're producing more particles. In the second equation, there is going to be a decrease in entropy because you're going from a liquid to a solid. And in the last example, there's going to be an increase in entropy because you're going from a solid to a gas, and gas particles have the most disorder. So let's look at this practice. Pause the video and unpause when you're ready. Great, well, welcome back. Well, in the first equation, we have two aqueous solutions combining to make a liquid. Aqueous things have more entropy, so there's a decrease in entropy in this case. Same thing with this one. We have two aqueous things combining to make a liquid, so again, there's going to be a decrease in entropy when that happens. Let's look at this practice problem. Pause the video and unpause when you're ready. Great, well, welcome back. So at what point on the heating curve has the most entropy? The most entropy is going to occur at point F because it is the highest. But if you said line segment E to F because that's where gases are, you are also correct. Let's look at this practice problem. Pause the video and unpause when you're ready. Great, well, welcome back. Which reaction will occur spontaneously? The reaction that will occur spontaneously is going to be the one that has the least amount of activation energy. Remember, activation energy is the distance from your reactants to the top of your peak. Example A has the least amount of activation energy. Example B has the most. Example A is also exothermic, which is also a key that it would happen spontaneously, where option B is an endothermic reaction. So the best answer for this question is option A, because it is both an exothermic reaction and it has a small activation energy. Let's look at this practice. According to table I, which reaction will occur spontaneously? Pause the video and unpause when you're ready. Great, well, welcome back. You should have discovered that option B is going to occur spontaneously because it is exothermic. All right, let's look at this, check your understanding. We're going to talk about this first thing in class tomorrow. Have a good day.